All right, the next topic is section 12.4, which talks about geometric series. And we all remember that word. That's multiplier and divide. Now, just like an arithmetic series, a finite geometric series also has a sum. The sum of the first n terms of a geometric series is given by the formula S sub n. The sum of the first n terms is equal to the first term in the pattern times 1 minus the common ratio to the n power, the whole thing divided by 1 minus the common ratio. So the pieces of information that you need to know a sub 1, which is the first term in the pattern. You need to know n, which is the number of terms you're adding together. And you need to know r, which is the common ratio. If you need to pause the video, write that formula down, highlight it in your notes, do whatever you got to do to make it stand out. Example number 1. 2 plus 4 plus 8 plus 16 plus plus 128. It's a sequence, or it's a series that ends. Well, what's the pattern? Well, I think you can all tell me it's timesing by 2. So therefore, it is a geometric series. Now, let's write it using summation notation. The sum from n equals 1, the first term. Oh, we don't know how many terms there are because of this dot. Ooh, so we have an issue. We don't know the top number yet. But we can write the formula because the first number is 2 and the common ratio is 2 to the n minus 1 power. The problem is, what is this number right there? We need that number. We need to know how many terms we're adding together. Well, you could sure do this in your head, but when it gets complex, you need to go back to the explicit formula, which says this. And we need to fill in what we know. Now, we know the nth term is 128. That's the last term. We know the first term is 2. We know the common ratio is 2. And we're trying to solve, we need to know what n is. Well, if I solve this, I'm first going to divide everything by 2, so those cancel out. So I get 64 equals 2 to the n minus 1 power. Well, we need to think, 2 to what power is 64? Well, if you figure that out, you're going to find out, I believe, that answer is 6. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times the 6th 2 is 64. Therefore, n minus 1 has got to be equal to 6. If n minus 1 equals 6, that means our number of terms in this pattern way up here, n is 7. Okay, good. So we're going to put 7 in the box. We're going to go from 1 to 7. Now we can use our formula. Go back a slide. This big formula right here written in red is what we're going to use. The sum of the first 7 terms of this pattern is equal to a sub 1, which is 2, parenthesis, 1 minus the common ratio to the n power, 2 to the 7th. The whole thing divided by 1 minus the common ratio, which is 2. Now we need to simplify. 2. What is 1 minus 2 to the 7th power? Well, 2 raised to the 7th power is 128. Now, if we go 1 minus 128, you're going to get negative 127 in the middle. And on the bottom, 1 minus 2 is negative 1. Now, if we simplify that, Negative 127 times by 2 is equal to negative 254 divided by a negative 1, and you get an answer of 254. So 2 plus 4 plus 8 plus 16 plus ... is equal to 254. Example 2. Find the sum of this geometric series given by the summation. We need the first term. Therefore, we need to put 1 in for n and figure out the first term. Well, 1 minus 1 makes a power of 0. Half to the 0 power is 1 times 4. The first term is 4. We need the common ratio. Well, that's in the parentheses. The common ratio is a half. I'm going to write it as 0.5. Finally, we need to know n, how many terms there are. Well, it says n starts at 1 and goes to 20, so that means there are 20 terms in this geometric series. So the sum of the first 20 terms in this series is going to be 4, the first term, times 1 minus 0.5 to the 20th power, the whole thing divided by 1 minus 0.5. Let's simplify that. Well, first of all, 0.5 to the 20th power is almost 0. It's almost 0. If you actually do it on your calculator, 0.5 raised to the 20th power is like a very small number in scientific notation. Now, if we add 1 to that, you get a number of about 0.999990463. That's what this whole piece in the parentheses comes out to be. And you're going to times it by 4, and then 1 minus 0.5 is 0.5. So when you do this on your calculator, you times by 4, and you get a number that's almost 4, and then you divide by a half, and you find out that the sum of the first 20 terms in this pattern is 7.99992371, which is approximately 8. And that is the answer to the sum of that geometric series, that finite geometric series. That's how you do finite geometric series. Any further questions, please discuss it, and let's ask each other in class.